Hi guys, welcome back to another video. Today we're going to be looking at the following problem from Mathcounts 2021. And we have a view of the problem below, so let's get a quick read. So the problem is, in the figure, two circles of radius 1 are internally tangent to a circle of radius 5, so that the centers of all three circles are collinear. The shaded region, or the shaded fourth circle, is tangent to each of the other three circles as shown, and we're asked to find the radius of the shaded circle. So let's zoom into this picture a little. So if we start with the first thing they tell us that the two circles of radius 1 are internally tangent to the big circle of radius 5, as we can see. And it says all centers of the three circles are collinear. So let's just make sure we don't forget this by drawing a straight line through the three centers. Let's draw a little straighter. Looks something like this. Okay, so just right away we know that these, so this is basically the diameter of the big circle, right? Because it goes through the center, obviously, and there's two endpoints. So each of these sides would have length 5. Now let's draw in the other centers we have in this problem. So we have this center, and the center of the shaded circle we can see is right there. If we connect the center of the small circles to the center of the shaded circle, it's going to go through this point of tangency, right? Just because that's how these circles work. And what we can also do is extend this, or we could actually leave that for now. So we want to find the radius of the shaded circle. So right here, let's call this x, right? Just so we know that x is what we have to find. Okay, so we call that x, and we know that this piece right here is 1, right? Because it's a radius of the small circle. Okay, and then now the other thing is, we know that this right here is 1, so that means that this region right here has to be a 4, right? So if we erase this 5, we basically know, we know that the whole radius of the big circle is 5, and because the small circle has radius 1, then we have a radius of 4, or not a radius, but side length of 4, as we show here. Okay, so we also know that this is a 90 degree, right? Because you have a chord and just the line dropped from the center to that chord. So we know that's perpendicular. And now you might think, okay, so we have a right triangle and we have two of our sides. So let's think of any way we can express this third side right here, right? So how would we do this? If we were to extend this, we know that, here, let's pick a different color. If we extend this, we know that this region right here is a 5, because this is just your radius of the big circle. So we know that 5 represents from this black dot here up to the top. And then we also know that this right here is x, right? Because we're calling x to be the radius of our shaded circle. So that means that we have this right here is a 5 minus x, right? Because we want this line plus this line to equal to 5. So this seems pretty cluttered, so let's pull this triangle out. We basically have this, we found this 5 minus x. We have a right angle here. This base is 4, and we have 1 plus x as our hypotenuse. So now this cluttered diagram just becomes basically, this right triangle, and we just have to solve for this right triangle, right? So now if we zoom in, this isn't too bad to do, right? We just do 4 squared plus 5 minus x squared equals 1 plus x squared, and that's just from the Pythagorean theorem. 4 squared is 16, 5 minus x squared, that is 25 minus 10x plus x squared. And this is equal to 1 plus 2x plus x squared. So immediately we could cross out these x squareds, and what are we left with? 16 plus 25 is 40, or 41. So you have 41 minus 10x is equal to 2x plus 1. So we could write this as 40 is equal to 12x. And we solve x is equal to 40 over 12, which is just 10 thirds. So we have x equals 10 thirds. And if we just go back to the problem is asking us to find the radius of the shaded circle. And if you remember, we call the radius of our shaded circle to be x, right? And we already found x is just 10 thirds, so our final answer would be 10 thirds. And they're asking for the answer as a common fraction, so we are done. So that should conclude this question. If you have any questions about how we solve this, be sure to leave a comment. And if you enjoyed the video or found it helpful, feel free to like or subscribe. It really helps out. And that should be all for today. So thank you all for joining, and I'll see you again tomorrow for another problem.